All right, let's implement this backward function, backward method first together. To implement this part, we first need to retrieve some numbers like this. And the out has the same shape as the output of this convolution layer. And we need to change this one as 1D vector so that we can process the out with these flattened variables. And how do we do so? We first transpose these as this, because we want channel to go to the back, and reshape -1 and number of filters like this. And dB is going to be NP sum DL. Why is it so? Because this bias gets added to all the values. So we know that the output of this layer is W times call W times plus B. And this bias receives all the upstream gradient. That is the principle. And how do you calculate dW? To calculate the gradient in respect of this value, we just multiply the upstream gradient with call. Do you remember that? So it is simply NP dot self call gets transposed and multiply that value with the out. After that, we are going to recover the shape of dW like this. Fn, C, FH, FW. Okay. And what is the call? The call is NP dot the out self call with, not with, H, kernel, and transpose. After that, what we are going to do is call this call to im function and get the original shape. And then we return EX. So this is the implementation of backward. This might look somewhat tricky at the first glance. However, basically what we are doing is same as the previous implementations. All right, because we are calculating, because we are viewing these as 1D, this implementation became simple. However, if we try to implement this as 2D or using for loops, then calculating this backward might become trickier. Okay. All right, let's go back to call to im and implement this part together. We first need to retrieve some numbers and see HW. This is going to be the input shape, the original input shape. And we want to calculate the up H and up W. This is going to be times pad minus filter width height, like this. Okay, and we need to reshape the column like this. Out H, out W, C, filter H, filter W. So this one looks like this. However, we transposed here. So after transposing 4, 5, out H and out W became the second and third dimension here, and we are retrieving these values here, and we want the original shape like this. NC filter H, filter W, out H, and out W. To do so, we are going to perform transpose. So these two dimensions go to the back here. To recover the image, we are going to first initialize a zero array like this. NCH plus 2 times ped plus stride minus 1, W plus 2 times ped plus stride minus 1 like this. For Y in range filter H, we calculate the maximum value. For X in range filter width, X max is X plus stride times out W. And we get the original values like this for Y to Y max with the stride size specified, and X max with the specified stride size. We are going to add the column values like this. So we are doing the opposite operation here, like this. Okay. And we return the image. And we want to remove the padding. So we are from pad to H plus pad, and W, pad, W plus pad. This will remove the padding. Okay.